Welcome back. Today I wanted to go over creating a program in PyCharm. For lab activity 2 and then moving forward, the process is going to be that there's going to be a part 1 and a part 2 of the exercise. And part 1 is going to be to create the algorithm that you're going to be using to create your solution in Python and PyCharm. So I thought I would go through this with you here that you could use moving forward. And the screen that you see in front of you should look familiar. What it is I'm actually coming into PyCharm, and I'm going to create a new project, which is the first step in creating a solution. And then I'm going to point to my G drive. So if you'll notice that the location for this particular source code project is located on my C drive, and my C drive is not where I want the code to be. I want it on my G drive. So what I'm going to do is I'm going to click on the ellipsis icon on the right-hand side. And when I do that, I'm going to scroll down to the bottom where I have my G drive. And you'll begin to notice something familiar appearing. You'll see my home directory, and then I have my summer 2018 directory, and I have my CS151W01 file. And I have a special directory that I'm putting my code into, and it's called test. And I created a folder called sample for today. I'm going to click OK. And now you'll notice that the location of the source code project file is located on my G drive. And this is the directory structure actually leading to the place where I want it to go. Now yours is going to be different because you're going to be putting yours into the appropriate file folder like lab activity 2, 3, and so on. But I did want to show it to you. The next piece I wanted to show you is right here. This is the interpreter. This is going to prevent you from having to get that yellow banner on the top of the screen that says that there's no Python interpreter. So notice mine says Python 3.6, which is exactly what I want. But just in case you don't have that on yours, I'm going to go ahead and click on this little arrow to expand. And you want to make sure that you click on existing interpreter, and it should say Python 3.6. If it doesn't, you should be able to select it by the pull down and make sure that it has Python 3.6. It could be Python 3.6, Python 3.6.5, 3.6.4. It doesn't really matter as long as it has some version of Python 3.x as the interpreter. Now, once I have that, I'm going to go ahead and click on Create. Now, in my case, it's saying that my folder is not empty. There's a reason for that. I actually have my pseudocode in a text file that I want to go over with you inside of PyCharm. This is not typically something you would be doing, but I actually have everything in one folder, and I'm going to show it to you in PyCharm. So I'm going to go ahead and click on yes to say, yes, I understand that it's not empty, but I want to create the source anyway. So I'm going to go ahead and do that. And it's going to take a few moments. Now, this is something that I wanted to share with you also. Since you've connected your computer to the G drive using my work drive, it may take 15 to 20 seconds for it to create the files that it needs on the G drive. Now, you notice that it just went through. Now, if you look on the left-hand side here, on the left-hand side frame, this is the file, the folder that I'm using. But if you notice, if you hover over that folder, you'll see the actual location, which is on the G drive, home, summer 2018, CS151, and so on. So don't be discouraged, just be patient. It's going to take a few moments to transfer the appropriate information over to the G drive, which is outside of your computer. So just be patient. So if you recall from lab activity 1, step number 2 in creating a Python source code file in PyCharm, step 1 was to create the project. Step 2 is to actually create the Python file. Now, what I'm going to do is I'm going to choose that. This is the folder that it's going to go into. I'm going to choose File, New, Python file, which you should be familiar with from lab activity 1. So I'm going to go ahead and choose Python file, and I'm just going to call this sample.py and choose OK. So what it's going to do now, it's actually going to create that file on the G drive in that specific folder. Now, see, it did take a few seconds, but Now you're ready to start writing your code. Now, I happen to have a second file here that I wanted to open up to go over with you first, because this represents the 5-step programming process that we're going to be going over for every single program when we work in Python. So I'm going to open this file up so you can see it. This is a text file that I created for a problem that we're going to be working with and for this demonstration. And it actually has the 5 steps. So the first step in the 5-step programming process is to define the problem. And for this activity, what we have is a school teacher was asked for us to write a program for her kindergarten class. It's going to take a couple of values, and it's going to output the result of adding the two values together. Pretty straightforward and simple. Now, we're going to use this particular program in other examples, but I just wanted to show you the real basic foundational version of this program. So that's our problem. The second step in the 5-step programming process is to develop our pseudocode. The pseudocode stands for fake code. It's not really real Python code. And you'll notice that this doesn't really look like Python. The only thing that we really know in Python is the print function. But this is just telling us in English-like language exactly what the program is supposed to do. First, we're going to start the program, because every program has to have a start and a stop. So we're going to start the program. The next thing we're going to do is we're going to declare and initialize our variables. That's the information for lab activity number 2. Then we're going to query. We're going to ask the user what the two values are. We're going to use integer values, and we'll take a look and see how we can do that. Then we're going to perform the addition on the two values. In this particular program, we're then going to display the results to the screen, and then we're going to terminate. Very simple. Now, step number 3 in the 5-step programming process is actual formal Python code. Now, we're going to develop the code in PyCharm. That's why I didn't add it here. But once we get it done, we have to test our program. That's step number 4. In step number 4, we're going to develop cases as to what we're going to enter. So if we're going to be adding two values to our together and outputting the results, the first step would be if the first value is equal to 2 and the second value is equal to 3, you add those two values, you should get the output showing the value 5. If we had 2 and 7, the output is 9. If we had 2 and 4, the output is 6. So this is the test data we're going to use later on to get this thing tested. And the 5th and final step in the 5-step programming process is documentation. And that's an overview as to how to run the program, what the user is expecting when the program is executed, and then what the results should be to the screen. This particular case, it's a very simple program, so the documentation is rather straightforward. But as the programs become more sophisticated, your documentation is going to get a little more complicated. So let me go back to my Python source code window. And what I'm going to do is I'm going to start by adding some comments. This way we can see what this is going to do. Your comments will be much different. Refer to lab activity 0 and lab activity 1 for what the information is going to look like. So you'll have your comment block at the top. Sample program to add two values, two integer values together, then display results. So I don't have to put these comment pieces in as far as the sequential hashtag. It's just to make it look almost like a box. So if we go back to the algorithm, first thing we're going to do is we're going to declare and initialize our variables. We have to come up with some variables that are meaningful, and they're self-documenting, which means that if you look at the variables, it's pretty straightforward as to what they are. I'm going to choose the variables first value, and I'm going to initialize that variable to a 0 to make sure that the memory location used to hold the data for that particular variable is initialized to hold the quantity 0. Second value, I'm also going to do the same thing. The sum, I it looks like I want to use the variable computed sum to hold the summation of the two values. So computed sum is equal to 0 right now. I just want to make sure that that memory location is just holding a number that I understand what it is. If we were going to initialize a variable to a string, we would, so if, for instance, if I were to say first name, and I wanted to hold the user's first name, but I wanted to clear that memory location out, I would do a quote quote. And what that does, it has the effect of clearing out the memory location, but telling Python that what's going to go into the location name first name is going to be a string or a word. But since I don't have a need for a string in this program, I'm not going to use that variable. So that's the initialization process. So going back to my algorithm, declare and initialize variables. I've already done that here. The next step is to perform the addition, to query the user for two integer values. Now, if you recall from looking at the information leading up to lab activity number 2, the way we query the user for information, for data, is you use an input function. So the first thing that I want to do is I want to get my first value from the user. So first value is equal to, now I'm going to just put the function in, but we're going to have to do something to this before we can run this program. And so what the input function requires you to do is to put the question that you want the user to see when you execute the program. So I want the user to see, please enter your first integer value. I'm going to put a quotation, a colon after that, and I put a space, and you'll understand why when we execute. The next thing that I want to do is I want to ask the user for the second value. So second value is equal to input, please enter your second integer value. Okay. Now I said before that we have to do something if we want to get this thing to run right. One of the issues that Python has is that when it allows you to use the input function like we did here, the assumption is that the data that's being pulled in from the user is a string. Now, these are obviously going to be requesting numbers, but even though we're pulling a number in, if we use it the way that it's listed here as an input, Python will interpret the value that we enter as a string, not a number. So in order to tell Python that we need this input as a value, a numerical value, not a string, we have to do one of two things. The easiest way to do this is to tell Python what's about to be input is going to be an integer. And what you do is you put the prefix for integer before the input function. It's actually formally called a typecast operator. We're trying to tell Python that what's about to be entered is an integer, and the prefix for the integer is int. And the way that you tell Python what's about to be entered is an integer is you have to surround everything by parentheses. So the meaning of line 10 of this line of code is place into first value the integer of the value that the user is going to enter when this program is run. The int prefix tells Python to convert whatever the user is entering into an integer value. Now, in subsequent lab activities, you're going to find that if the user were to type in a word and Python tries to convert it to an integer, there's going to be an error, but we'll get to that at a different time. So I want to try it again on the second line of code on line 11, but I want you to see something when I do that. int, Remember I said we have to surround everything by parentheses, but I want you to notice something. I only entered the opening parentheses. And if you'll notice at the end of the line, that little red squiggly line, that means that PyCharm is trying to tell you there's a problem here. You need to fix it or else you're going to run into a problem with the interpreter. Now, most people disregard those little squigglies because they're used to Microsoft Word, where they put the little red line in, and most people don't even bother with it. But in this particular case, in PyCharm, you better pay attention, or else if you attempt to execute, you're going to run into a problem. So let me just put it in here to make sure that this program runs error-free, and then we can go back and to try to remove that closed parentheses so I can show you that the error really does occur. Now, the next thing we're going to do is, first we have our declaration here. So what I can even do is I can put a comment here. Declare and initialize variables for program. Now, a comment does not execute, so I don't have to put a comment on every single line. I can put a comment anywhere that I want, to the right-hand side of an active line of code, above an active line of code, it doesn't really matter. So putting it to the right-hand side, I'm just basically saying I'm declaring and initializing the variables for the program. This time I'm going to put the comment above the line of code. So what I'm going to do here is I'm going to say get integer values from the user. Something very simple. So we're done with that part. Next thing I'm going to do is I'm going to say to, at the comment, basically comments is a non-executable line of code that tells the user what's going on. Here I'm going to say calculate the sum of the two values entered by the user. So in calculations in Python, there is a very specific protocol in which to create the equation. The variable accepting the equation must be on the left, and the work that you're doing is going to be on the right. So the variable that we're using to hold the sum of the two values is computed sum. The first value variable and the second value variable hold the user's values. I was going to say answers, but it really is values. So I'm going to do the equation. Computed sum is equal to first value plus second value. Now, pay attention to what we've just done there. This is what the equation looks like. The variable accepting the work, in this case computed, I made a mistake with the variable. It should be computed sum, not computer sum, is equal to first value plus second value. That's the work that has to be done. So Python will take whatever numbers held in the variable first value, then take whatever values being held in the variable second value, add them together, and place the answer into the variable computed sum. So according to our algorithm, we've declared and initialized the variables. We've done a query of the user for the two variables, to the two values. We perform the addition. The only thing that we have really left to do is display the results to the screen. So you are familiar with the print function because you did that in lab activity number 1. Now we're going to get a little bit more involved, and we're going to use the print function to get the information, the data that's held in the variable computed sum, to the screen. So let's go ahead and put a comment in. Display the sum of the two values from the user to the screen. There we go. So in this case, we have to do print, open parentheses. Now, what the print function allows you to do is to print two different types of data. Literal data, which is what you did in lab activity 1. You put in quotation marks exactly what you wanted to the screen. Literal data means you want literally to put that information to the screen. Print also allows you to enter or to display data that's found in a variable if you wanted to. So we need to do both. So what we're going to do is I'm going to output the information. The sum of the values entered by the user is, and that's what we wanted to say first. And then what I wanted to do is to output what the value is held in the variable computed sum. So I'm going to put computed sum. Okay, I don't know what it's going to look like, but let's try to run this because this is really what the program looks like. And let's see if it works. So just do a quick scan. I have my comments. I got my declaration of variables and initialization, which means I actually put something into those variables. Next thing we're going to do is we're going to get the values from the user, and we're going to hold them in first value and second value. Recall from our discussion earlier that we put an int prefix, which tells Python to convert whatever was being entered by the user into an integer. Then we're going to take those two values and add them together, and then we're going to display them to the screen. Let's see if it works. So the good news that I wanted to share with you is that as you're typing, PyCharm is taking the responsibility of making sure that the code, the source code, is actually being stored automatically for you in the source code file, in this case, sample.py. All I have left to do now is to run. So I'm going to go ahead and click on Run. Third option down is Run, and you should get a little window, and you notice that the name of the program is located here. And I'm going to go ahead and click on Sample. And if this works, what will happen is you'll get a screen at the bottom, which is going to be our output. And here we go. So this is our output window. And PyCharm is doing exactly what it's supposed to do. It's interacting with Python. Python is interpreting our source code, and it's coming up with the first line of code that requires user input. Now, if you look at line 11 in the source code above, line 11 says, please enter your first integer value. That's exactly what's being asked on the screen. So I'm going to go ahead and choose in our source code, I think in our test case, if first value equals 2 and 3, so we should get an output of 5. So let's try that. You have to click down in the output window, and you notice that little I-beam flashing. I'm going to press the number 2 and press Enter. Next thing was the value 3, and I'm going to press Enter in a moment, but what's going to happen when I press the Enter key, Python will execute line 15 of the code, the source code, meaning it's going to add the two numbers, 2 and 5, put the result in computed sum, and then it'll go to line 18 and output the line. Let's see what it looks like. I'm going to press the Enter key, and there it is. The sum of the values entered by the user is 5. Now, do you like the way that looks? I mean, it looks okay. I'm going to try something which I shared this information as one of the files that I wanted you to download. And one of the files that I wanted you to look at was something called the escape codes. The escape codes shows the codes that are necessary to create an enhancement to the output. Now, this looks okay, but it looks kind of bunched together. What I would like to do is to take this, please enter your first integer value, and go down a line. And then I would like to take this line of code where it says the sum of the values entered by the user is 5. I'd like it to be indented by 1 tab. So let's see how to do that. I'm going to go up to my source code, and I'm going to enter the escape sequence or the escape code for the new line. So the escape sequence or the escape code for a new line character is \n. Now notice where I put the \n. It has to be inside the quotation marks of any output statement, print or in this case, input. So inside the quotation marks, I put a \n, which is going to force the first line of output to go to a new line. The next thing I'm going to do is I'm going to put the escape code for a tab at the bottom of the, as the last line of code, so that the actual output indents by one tab character. So \t, if you look at the list of codes, \t is a tab character. Let me just run the code this way so you can see what it looks like, so you can see the enhancements. Notice this is the old way. As soon as we run, we have please enter the first integer value, please enter the second integer value, and then directly below that it says the sum of the values entered by the user is 5. Let me execute the line of code again. Notice that once you run the code first, in PyCharm, you now have the ability to see some of the additional features that are available in PyCharm, where if you click on that green arrow here or here in the upper right quadrant, you can execute the code again. Or if you feel comfortable, you can click on run and run. It doesn't matter. So I'm going to go ahead and choose sample. And I want you to take a look at the screen. Once the program starts to execute, it will start to run. Now, you notice it took a little bit of time to run because it's actually getting the information from your G drive. But notice there's an extra space in here now. In the output window, we're getting the same output, but you get an extra space. If you want 2 spaces, \n. If you want 3 spaces, \n. Each \n tells Python it's an escape sequence code, which allows Python to say, okay, I guess they want a new line. So in this particular case, I'm going to put the same data in, 2 and 3. Now, when I press the enter key, what should happen is the last line of output, line 18 in this case, should be indented by one tab character. And there it is. So we have, it looks a little bit more refined. And this is exactly what you need to be doing as a programmer, where you execute, you modify, you execute, you modify your source code until you get it to the way that you want it. Now, I want you to see one thing before we do any type of other modification. You recall when I showed you the int prefix, when I said this is called the typecast operator, where the int tells Python to convert whatever the user enters as an integer. And I said you have to surround everything following that with the parentheses. I'm going to get rid of that last parentheses. And I want you to see that PyCharm is identifying this as an error, because it's got that little red squiggly line. It's even telling you, if you hover over the red squiggly line, it's telling you either a comma or a closed parentheses is expected. Now, most people don't pay attention to the yellow little tags, and they say, I know better, I just want to run anyway. So if you try to run, what's going to happen when it attempts to execute, and you'll see this in a moment, you're going to get a different kind of a screen. Now you've got a problem. It's specifically telling you that there's a problem. There's a syntax error. A syntax error means there's a problem with Python language. Now you look at this and say, wait a minute, this doesn't look bad. Computed sum is equal to first value plus second value. There's nothing wrong with that line. And you'd be right. There isn't anything wrong with that line. But because the previous line is expecting a closed parentheses, it's thinking that line 15 has got a problem. So it doesn't always necessarily mean that line 15 in this case is an issue. It may mean you have to look up by one line in order to see what the problem is. I noticed that there's a missing parentheses. I put that in, red squiggly line goes away, and I can execute my code. This time what I want to do is I want to try a new set of data. I'm going to put the data in as 2 and 7. I should get a 9 at the output. And then I'm going to make one more modification, and then we'll call it a day with this particular demo. So I just hit the run button. It'll take a few seconds for it to appear. I'm going to put 2, 7, and the output is 9. The only other modification that I want to do here is I really don't want that output statement to say the sum of the values. I would like to have the values as part of the line. So it would say the sum of, in this case, 2 and 7 is 9. Let me show you how to do that. Remember I said that the print function allows you to enter two types of data, literal and variable. So in this particular case, what I want to do is the sum of, I want to get rid of this. The sum of, I'm going to put whatever was being held in the variable first value. And notice that I'm putting a comma in between each of these pieces in the print function. So the sum of first value and let's put in second value is equal to computed sum. Now I may have to modify this. So the output is going to say the sum of 2 and 7 is equal to computed sum. Now, the way this reads is that what Python will do is it'll take whatever's currently held in first value and replace this word first value with the number. It'll replace second value variable with the value, and whatever is held in computed sum, it'll replace it with the number. So let's try this again with 2 and 7. Let's run the code. In a moment, it'll clear the screen, and here we go. 2, 7. When I press the enter key, the sum of 2 and 7 is equal to 9. It replaced the variable reference in line 18 with the actual value held in the variable first value to display it on the screen. So that's what I wanted to go over with you in this particular demonstration. Let's take a look at our algorithm to make sure that we're okay. We have our problem statement. We actually developed our pseudocode, which is exactly what you're going to be doing in part 1 of every lab activity moving forward. You're going to be sending me the the algorithm as part 1, which, just as a side note, lab activity number 2, part 1 is due tonight at midnight. That's Wednesday the 20th. That was a quick commercial break. But once you have your algorithm done, you develop it in PyCharm from an approved algorithm. I'll send you the algorithm back by tomorrow morning. Once it's approved, you start generating your code, and then you come up with the kind of data you're going to be using to test your program, and then you develop your documentation. Okay? So I think we're done with this particular program. I'm going to close out of this. And I think we're done with that. So I'm hoping that this video was helpful, and I look forward to seeing you when we're in our next video. See you on the other side.